Assalamualaikum girls. I am Shamsunisa from Royal Degree College, Chemistry Department. As we are talking about second unit Organic Chemistry, Chapter 1, Amines, Cyanides and Isocyanides. Today we'll deal with nomenclature of isocyanides, preparation of isocyanides and chemical properties of isocyanides. Nomenclature. So in these compounds, the carbon atoms of the alkyl or aryl group is attached to the functional group through nitrogen atom. These are named as isocyanides, isonitriles or carbylamines. See the example here, CH3 and triple bond. Here the two bonds are different and the third bond is different. Third bond is the with arrow we are representing the bond, that is the coordinate covalent bond going to attach with the carbon. So CH3 NC. NC is the isocyanide. Okay, CH3 is methyl. So methyl isocyanide. It is named as or methyl carbylamine. Next one, CH3 single bond, CH2 single bond and double bond, then the coordinate covalent bond with carbon. So here the two carbon atoms are present attached to NC. NC is the isocyanide. So ethyl isocyanide. It is named as or ethyl carbylamine. Next example, C6H5 and double bond. Then another bond is the coordinate covalent bond with the carbon. So this is named as phenyl isocyanide. C6H5 is phenyl and C is isocyanide, or it is also named as phenyl carbylamine. Now we'll see the preparation of isocyanides. From alkyl halides, when ethyl iodide is heated with silver cyanide in aqueous ethanolic solution, methyl isocyanide is formed. See the reaction here, C2H5I. C2H5 is ethyl, I is iodide, ethyl iodide. In that we are adding silver cyanide, AgCl, and we are providing heat. Then here, from ethyl iodide, iodine is coming out. In place of iodine, from silver cyanide, NC, it is cyanide group, it is turning and attaching to the ethyl group as NC. So NC is nothing but the isocyanide. Okay, C2H5 is ethyl. It is named as ethyl isocyanide. Then another product what we are getting, Ag remains here, na? That Ag will react with iodine and we are getting silver iodide. Next preparation of isocyanide is from amine. When ethylamine is heated with chloroform and potassium hydroxide, ethyl isocyanide is formed. It is called carbylamine reaction. See the reaction, CH3, CH2, NH2, that is ethylamine. In that we are adding chloroform, CHCl3 is the chloroform, and 3 moles of potassium hydroxide, and we are providing heat. Then here what is happening in ethylamine, from NH2, these two hydrogen atoms are coming out. In place of that, those hydrogen, one carbon from the chloroform, it is going to attach with the nitrogen. So here we are getting CH3, CH2 and C. And C is isocyanide. So CH3, CH2 is ethyl isocyanide. Then 3 moles of potassium reacting with this 3Cl and we are getting the 3 potassium chloride. And another side product is 3 moles of water. When aniline is heated with chloroform and alcoholic potassium hydroxide, phenyl isocyanide is formed. See the reaction, C6H5NH2, aniline. In that we are adding chloroform, CaCl3 and 3 moles of potassium hydroxide and we are providing heat. So here from aniline, from nitrogen of the aniline, we can say the 2 hydrogens are coming out. In place of those 2 hydrogens, 1 chlorine from the chloroform, it is substituted there. So we are getting C6H5NC. So it is named as phenyl isocyanide. And another product is 3 moles of potassium reacting with 3 chlorine, and we are getting 3 moles of potassium chloride. And the another side product is 3 moles of water. Now we'll see the chemical properties of isocyanide. First property is hydrolysis. Ethyl isocyanide on hydrolysis with mineral acid forms ethylamine and formic acid. Look at this reaction, CH3, CH2 and C. What it is named as? Ethyl isocyanide, isn't it? In that we are adding the 2 moles of water. Hydrolysis reaction is taking place in the presence of acid. So H plus we are writing on the arrow. Then here from ethyl isocyanide, this carbon is coming out. Okay, in place of that carbon, 2 hydrogens from water molecule is attached with the nitrogen. So we are getting CH3, CH2, NH2. It is named as ethylamine. Then another side product here we are getting one, that is, as one carbon atom is coming out from this side now, reacting with one hydrogen, and the 2 oxygens are there and one more hydrogen. Altogether the 4 hydrogens are present here, isn't it, in the water? 4 hydrogen. 2 hydrogens are substituted in place of carbon along with the nitrogen, and the 2 hydrogens here, it is going to attach with the carbon and oxygens. So we are getting HCOOH. It is named as formic acid. Next property we'll see of isocyanide, reduction. On catalytic reduction means in the presence of catalyst, reduction reaction will take place. Methyl isocyanide is converted into dimethylamine. So that dimethylamine is nothing but secondary amine. See the reaction, CH3 and C. It is methyl isocyanide. In that we are adding the 2 moles of hydrogen, and the reaction will take place in the presence of nickel catalyst. Then here, see, from methyl isocyanide, this carbon time being, it is slightly moving. Okay. Then in place of carbon, along with the nitrogen, one hydrogen will attach. Then the carbon will attach with that hydrogen. Then the 3 hydrogens remain here. Those 3 hydrogens are attached with the carbon. So we are getting here CH3, NH, CH3. How many methyl groups are present? CH3 is methyl. The 2 methyl groups, that is dimethyl, attached to NH. NH is the amine. So dimethylamine, which is nothing but secondary amine. Next property of isocyanide is oxidation. That is here nothing but addition reaction. Alkyl isocyanide form addition products with halogen, sulfur and mercuric oxide. See the reaction RNC we are taking, that is alkyl isocyanide. General reaction this one is alkyl isocyanide. In that we are adding halogen, that is X2. Okay, so halogen is added to the alkyl isocyanide. So we are getting here R single bond and double bond carbon, then X2. It is named as alkyl isohalide. Iso means NC is there, na? So that is iso. R is alkyl, NC is iso, X2 is halide. So alkyl isohalide. Next reaction, R single bond and double bond, and the another bond is the coordinate covalent bond with the carbon. That is named as alkyl isocyanide. In that we are adding sulfur. So what will happen here? We are getting the product as R single bond and double bond remains with the carbon, and another double bond it is going to be formed with the sulfur. Okay, then R single bond and double bond C, double bond S. So it is named as R is alkyl, okay, NC is iso, S is thiocyanate. Next reaction, you can see RNC, this one is also, that is alkyl isocyanate. In that we are adding mercuric oxide. As we are adding mercuric oxide in this, oxidation will take place in alkyl isocyanide, and we are getting here R single bond and double bond C and double bond with the oxygen. Then we are getting the side product as mercury. Okay, we are getting the side product mercury. Again, I'll explain this reaction. Listen carefully. The last reaction, that is, as we are taking alkyl isocyanide here, R single bond and double bond carbon. Then another bond will be there in between nitrogen and carbon, that is represented with the arrow mark, which is nothing but coordinate covalent bond. Okay, in that we are adding mercuric oxide. Then oxidation will take place in alkyl isocyanide. What is happening here? R single bond and double bond carbon, then double bond with the oxygen. It is forming the double bond with the oxygen. So R is alkyl, NC is iso, and O attached to the iso group, na? So it is isocyanate, alkyl isocyanate. Then mercury we are getting as a side product. Thank you for listening my lecture.